Okay, so moving on in our first chapter to measuring and classifying angles. So first, let's define an angle. An angle consists of two different rays with the same endpoint. So if you look at this angle right here, we have angle BAC. And the way I know that is because we're going from B to A to C. It's like you're passing a ball. You could also name this angle CAB. This is the notation for angle. So you could have angle BAC or angle CAB. Shares an endpoint with two rays coming out in different directions. Ways we couldn't name this angle would be BCA, because that would make a completely different angle. You have to do it like you're passing the ball. It would have to be in either direction of BAC or CAB. Let's practice naming angles here. So if I wanted to name the 90-degree angle, and it's marked right in the corner, I'd have to name it angle ABD, or in the other direction, DBA. If I wanted to name this little 45-degree angle, I could name it angle DBC or angle CBD. Now, those are not the only angles in this picture. You could also name this larger angle in pink, and that angle would be angle ABC, or in the reverse direction, angle CBA. So there are two ways to name angles like this. Let's start to classify angles. You'll probably remember this from middle school. An acute angle. An acute's very small. It's cute. It's less than 90 degrees. Remember this notation: less than, greater than, equal to. Less than 90 degrees is going to look like a smaller angle. A right angle is going to be like a corner. And it will often be marked by this little square. And that would be exactly 90 degrees. It's like the corner of a paper or a book. It's exactly 90 degrees. An obtuse angle is going to be larger. It's going to be greater than 90 degrees. It's big, it's obtuse. Look like it has a big open mouth. And finally, a straight angle. A straight angle looks just like what it's called, straight across. Now this is exactly 180 degrees. Exactly 180 degrees. Let's practice classifying some angles. So if we're trying to classify angle ABD, ABD, I like to outline it like that so I know exactly what angle I'm talking about. It has it labeled how many degrees it is. 90 degrees. And if an angle is 90 degrees, that means that it's a right angle. That's the notation for angle, so you can use it shorthand. Now let's classify angle DBC. Let's draw it out like we're passing the ball. DBC. It says that that angle is 45 degrees. 45 is less than 90, so it's an acute angle. Next is ABC. Now that one's a little bit wider. And what we have to note here is that ABC includes both the blue angle and the orange angle, ABD and DBC. It's this whole thing. So that means that this is going to be 90 degrees plus 45 degrees. That's a little hint at what we're doing later. 90 degrees plus 45 degrees is going to be 135 degrees. And that's more than 90, which means this is obtuse. And finally, angle ABE, straight across. Remember, if an angle is straight across, it's a straight angle, 180 degrees. If we even added up all these angle measurements, 90 plus 45, you'd get 180. So that's a straight angle. So let's do the angle addition postulate. We actually just did it, even if you didn't know. If I have these two angles, angle RSP and angle PST, together they're going to make angle RST. The definition of the angle addition postulate is once I find it, all right, so the definition of the angle addition postulate is if P is in the interior of angle RST, then the measure of angle RST equals the measure of angle RSP plus the measure of angle PST. So let's take a second to look at what that looks like. Let's identify what these angles are. Angle RSP is this red one right here. And angle PST is this blue one. The if statement, the conditional statement, is P has to be on the interior of RST. And in this case, it is. It's chilling out right in the middle. So this is saying that these two little angles make up the larger angle. That may seem obvious, but it can help us solve some different problems. So let's look at this one. Find the measure of angle PTM. So we're looking for the large angles measure. Well, first, N is between angle PTM. It's on the interior. So we can use the angle addition postulate. From the angle addition postulate, we know that the measure of angle PTM, this is shorthand for the measure of an angle, is equal to the measure of angle MTN plus the measure of angle PTN. That's what the angle addition postulate tells us. So let's just plug it in and figure it out. The measure of angle MTN is 40 degrees, and the measure of angle PTN is 30 degrees. Now, if we were to add these up, we'd find that the measure of angle PTM is 70 degrees. That's how you use the angle addition postulate. Let's move this over so we have room. All right, so now let's use it in a more complex way. Given that measure of angle NRQ is 78 degrees, find the measure of angle PRQ. So let's make sure that we highlight what this is looking for us to do. It wants us to find the measure of angle PRQ here in pink. Given that NRQ is 78, NRQ, that's the whole thing. So let's use the angle addition postulate and then substitute the information we have. So the angle addition postulate is going to tell us that the largest angle, the one that's made up of the two small ones, so that's the measure of angle NRQ, equals the measure of angle PRQ plus the measure of angle NRP. All that's saying is that the large angle is going to be made up of the two smaller ones, or the two smaller ones put together make up the larger one. Now let's put in the information we know. NRQ is 78 degrees. The measure of angle PRQ, we don't know its exact measure, but we do know that we can call it 4x minus 1 degrees plus NRP, which is 8x plus 7. This is when we have to use the algebra that we practiced earlier this year. If we were to combine like terms, we'd have 8x and 4x together making 12x, and then 7 and negative 1 together making positive 6. So 12x plus 6 equals 78 degrees. If we take away 6 from both sides, we have 72 equals 12x. Now the way that we undo multiplication is division. So if we divide 72 by 12, we get x equals 6. I just switched the order there. So x equals 6. But did the question ask us to find x? No. It asked us to find the measure of angle PRQ, which means we need to plug in x back into it. So we have 4, and we know that x equals 6 minus 1. We put that into our angle measurement that was given to us for PRQ. 4 times 6 is 24, minus 1 is 23 degrees. So the measure of angle PRQ is 23 degrees. A lot of work, but that's how you use the angle addition postulate. And we can plug in those variables to actually find the exact angle measurements of our unknowns. Okay. Pause the video if you haven't gotten this written down, because I'm going to take it away. Moving on to congruent angles. Congruent angles describe two angles that have the same measure. Or it could be any number of angles with the same measure. Now, just like segments, angles themselves are congruent because their measures are equal. So measures are equal, but angles are congruent. And finally, an angle bisector. An angle bisector, if you can guess by its name, is a ray that divides an angle into two equal angles. Basically, it cuts it in half. Whenever you cut something in half, you end up with two equal parts. Those little tick marks on angles can show you that these two, meaning the ones in pink, are the same measurement. They are congruent. They have equal measures. You might also see something like this with tick marks, just like our segments. That also means that they have equal measures. So if you have YW cutting right through angle XYZ, then that means that the measure of angle XYW is the same as the measure of angle WYZ.